Hey, hi champs of EXAMSNet. This side Uttam Tiwari, your all-time expert of this subject. From now, we are starting the lecture series of the physics course. I will be covering the 11th and 12th portion in a very detailed manner from basic to advanced. We'll be covering the first chapter to the very last chapter of the subject. Throughout your course, I will be ensuring that each one of you get their doubt clear at easiest way possible. For that, even we are handling two-layer live doubt system. The link for Telegram channel is already given in the description box. Throughout the course, I will be giving you actually the buckets of short tricks, I must say, because that would directly enhance your performance in the exam time. Also, I'll be ruling my prediction over three repetitions of question in the form of PYQ in the upcoming years. Because if you follow certain trend of different exam agencies, nowadays they are following a PYQ trend, right? This PYQs are keep on repeating in the upcoming years. So this chapter has a lot weightage, I must say. Generally, student tends to create a perception for unit and measurement. Let's do this chapter at the end of the course, or this chapter isn't important. But mark my words, let me tell you, exam analysis, NEET 3 to 4 questions were observed this year. JEE 1 question at every shift. EAMCET 1 to 2 questions at every shift. BITS 4 questions. So again, this chapter would directly ace your scorecard to the next level. So let's master this topic with me. I am your educator Uttam Tiwari, and let's study. Let's get into the topic. So somebody asked you what is measurement, right? So what sort of image you would directly create in your mind? Measurement is something related to accuracy. And when you try to link accuracy with physics, then you get a particular definition of physics. Physics is nothing but it is an exact science which gives you accurate knowledge about the nature and natural phenomena happening in this universe. The exactness, or you can say the accuracy, is the other word. Accuracy, both are same. So accuracy and exactness is directly dependent on the measurement we make. So how would you be improving your exactness or accuracy? By the measurement instrument which you are using, by the techniques which you are undergoing while measuring units, right? So we'll be studying a lot of things in the measurement. So let's go and read the definition first. What is measurement? The comparison of any physical quantity with its standard unit is called measurement. Now, somebody would ask you what is physical quantity and what is standard unit. Standard units and physical quantity are the units which are already predefined in the physics, right? So we'll be following certain units by which we'll be solving so many questions and we'll be solving so many concepts in that. So physical, what are physical quantities? So those quantities which are directly or indirectly dependent in the terms of law of physics and can be expressed as the units are known as physical quantities. So I can reread again. All those quantities which can be measured directly or indirectly in terms of which the law of physics can be expressed are called physical quantities. You all might have heard like this particular length of cloth is of 2 meter. This object is of having a mass 4 kg. Today's temperature is too high. My car is moving with 40 meter per second. The boy is putting 40 Newton force. The current flowing in our circuit home as like 4 ampere. So these kind of things you might have all heard of, right? So what are these things? These are all physical quantities which are already defined with the laws of physics. So now these physical quantities are divided into two parts. First is your fundamental quantities, the other one is your derived quantities. So now somebody would ask me what is fundamental quantities? These particular quantities are independent. They do not depend on any quantity. These are independent already. They follow certain 7 fundamental quantities. With that, we'll be defining other quantities. So these are length, mass, time, temperature, current, intensity, and quantity of matter. Other than if somebody thinks there could be any other fundamental quantity, please comment in the comment section. But they aren't possible anything you can define with just help of these 7 physical. fundamental quantities. Other than, if you talk about like velocity, you talk about acceleration, force, momentum, moment of inertia, flux. These all are derived quantities. They are derived from other physical quantities. You see, you derive physical quantities. You derive velocity again, length. What is velocity? Let's take an example of velocity only. What is velocity? Velocity is total displacement over time. So let's write total displacement, right? Total displacement over total time taken. So when you talk about total displacement, total time, so displacement again a unit of distance, that means length would come. Total time is again unit of time, so time would come. So other than, you don't need anything. You talk about acceleration, change in velocity upon time taken. So you see velocity is the need of distance and time. So again, you cannot derive with other things. Force, again, you need work done. So that would be again, force into the displacement would again comes from this part. So momentum, again, mass into velocity would come from this part. Again, everything are derived from the seven physical quantities. Other than, you cannot define any quantity. So these quantities would help and in the 11th and the 12th course of the physics, and even every course of the physics. Other than these quantities, nothing are possible. So yes, now, what was the need of measurement? We already know, like, okay, like you people got what are length, what is mass, what these quantities comes as time even, temperature even, current even, the intensity, a particular brightness, particular how much this amount contain the matter, yeah, the mass. So what was the need of measurement? Okay, so in the childhood you might have started, this length is there is one height, there is capacity in the weight. With this you can define the quantity. But what was the need of actually measurement? For in the old time, if we talk, there was a need particular, like why we call length as a length only, why we say that this is 1 meter only. For example, this is 1 meter, why this is not 2 meter? Or why we say this is a meter? Okay, I can say this is 2 liter. This particular length is of 2 liter. Why didn't I say this? Why I always count my height in the meters, in the centimeters? Why I always count my capacity in the liter? Why always I count my weight in the kgs and grams? Why so? Why can I not call this as a liter? Why can I not call this as meter? So I can even substitute this unit. But why do we are taking these particular units? That's the question. So actually, there was a lot discussion on this. Actually, there was old scientists making these kind of laws in the physics just to make our system so easy. So let's see like what was going in the discussion. Yeah. So we studied like what was the need of measurement, but now what particular measurement is? So let's read the definition. It is the process of comparison with the standard unit. So again, measurement, I told you, we are comparing something with the standard unit, the first line which we have started. There's a one formula, Q is equals to NU. Q is a formula for the measurement. Now, like, let us take example what this formula says to us. So, you know already, right? You are defining a scale. For example, you're defining a 1 meter scale. 1 meter consists of 100 centimeters. This you have started all in a child. So you have already defined a scale. Why we haven't said that 1 meter consists of 1,000 actually 1,000 centimeter? Why so? Because that was already taken into the system. 1 meter already. Somebody comes, some scientist has come, and already the to make our system uniform globally, they already have taken 1 meter equals to 100 centimeter. So what was the need of this particularly? So like I have taken example. Let the length of room is 5 meter. So if it is 5 meter, so 5 meter equals to 500 centimeter, right? Can you see one thing? This five is nothing but your magnitude, basically. Let's take here. Just a minute. Yeah. So this 5 is nothing but it's like numerical value. 5 is your numerical value of physical quantity. And what is U again? This what is U? This is a unit, right? Which you are converting like 100 centimeter. 1 meter consists of 100 centimeter. That's why you're calling 500 centimeter. That means this 5 into 100 is particular thing which you are doing, right? So 5 is unit numerical value. The magnitude and 100 is a unit. 1 meter equals to 100 centimeter. So that was what was defined as per the law of physics. So like this also follows some rule. Let's study that. For example, you have 1 rupees. With a clear understanding, you have 1 rupees. So 1 rupees consists of 100 paisa, right? So for example, I'm just talking 1 rupees. So which one is greater? For example, I talk 1 rupees and 250 paisa, or let's take 50 paisa. Just let's take 50 paisa. Which one is greater? Obviously, 1 rupees is greater than 50 paisa, right? So what can you comment on this? Can you see one thing? There is nu equals to constant, right? So you're defining this as constant. I already told you this is magnitude, this is unit, and that is equals to constant. But can you see n is inversely proportional to u? That means if you are increasing the magnitude, the unit is becoming shorter, smaller. And when you're increasing the unit, the magnitude is decreasing. So you can clearly see 1 rupees is one is a smaller in the magnitude, but it has a high unit. But 50 is bigger in the magnitude, but it has a low unit, right? So n is inversely proportional to u. This you can decipher from this particular point. So you can even get one formula, that is n1 u1 equals to n2 u2. So by this you can solve any numerical on this particular thing. If somebody has given you particular that this is 5 meter and the unit is 100 centimeter, and the other one magnitude like this is 5 meter, the other one unit you would be able to know because that follows a constant law. Okay, so yes. Let me clear up. Now, what was the need of this? I already told you, because to make system, globally accepted, it should be well defined so that it should not even change with time. It should not be reproducible, right? It should be internationally acceptable, accessible. These kind of things were going into the market. Some like earlier, there was system like different systems. System of unit you can see here. CGS system. Earlier in France, if you talk about, there was people were following centimeter for length, gram for particular mass, and second for time, mass, and for the length. They were following these units in the France. And then if you talk about FPS system, which was there in British, they were earlier following foot, pounds in seconds. Still, people, to flex, they say I have 20 pounds, but that's not correct, right? If somebody has given you already standard unit, so international systems of unit, we should always talk related to international system units. So earlierly in MKS system was even followed after FPS system. MKS was followed in the French again. So that time they were saying meter, kilogram, and second. So MKS system stands somehow correct for us, right? And that was uniformly accepted as a global cause of unit. So now we have defined already standard units. What was that standard unit? 7 standard units were defined in physics, and 2 supplementary units were defined in physics. What are these standard units? You can easily see length, mass, length. Just a minute. Yeah, length. So basic unit for length is meter, and the symbol is again meter, right? Mass, basic unit is kilogram. The symbol is kg. Time, basic unit is seconds. and symbol is second S, represented by temperature is Kelvin. We take always Kelvin as a standard unit. That's why if somebody gave you numericals, we always go for the standards unit because that is only accepted. Why to go for the different units? Every physics concept is based on the standards units. Now, if you try to change, so everything would get enhanced and changed to back. So that's Kelvin K. Current ampere. That's why we say 1 ampere current. Intensity again, it's candela. CD matter, it's mole. So we say mole, right? MOLE, mole for the quantity of matter. So these 7 units were MK system was observed, and this was accepted globally. Now, what was the need of particular supplementary units? So when we're trying to, other than 7 units, when we were trying to measure angles, when we were saying like this particular angle, that particular angle, so that time we needed basically this plane angle and solid angle. So basic unit for them is radian, and symbol is RAD. Solid angle is steradian, and SR is the symbol. So what is radian? What is steradian? Now question would be, let's study that. You can see this diagram of radian. What this diagram says, how we define radian. Radian is defined as the plane angle subtended at the center of sphere. You see, this is center of sphere, right? We have drawn a center sphere and we have made an arc to it. This is particular arc, you can see. There is a center to an arc. So when you subtend an arc with a radius r and length L, arc is there of length L, radius r. So when you take ratio of this length upon r, so you define angle theta subtended by that. So this is theta actually. Now, what is steradian? It is also similar. Steradian is nothing but, like let me take example of steradian. Steradian is nothing but it is surface area divided by radius square. We denote this with this sign. This is in a steradian sign, right? So steradian was even defined. Steradian is again a solid angle, and this is a plane angle. So when you define something with a solid angle at the center of sphere, then what you do, you take an equal area of a square having equal side to the radius of sphere. So you just need to know the formulas of this actually. And steradian, we don't use that much in the market, but this is something very important, and I'll be telling you very much numericals on this particular topic. So steradian is not that important, but radian you can expect questions, and the question have even been asked to this. So let's study this in detail. So supplementary quantities and their units. Yes. So when you talk about plane angle, you draw a circle. You talk about plane angle. Let me draw a good circle. Wait. So this is circle, for example, right? So you already know, right, that this is for full circle. You complete 2 pi revolution. So 2 pi radian, that we can say 2 pi radian of an arc which you are subtending. But from center, if you're drawing and you're covering an arc particularly, I'm considering a whole circle, right? So if you're drawing 2 pi radian arc, that means a complete circle. So that would be covered in 360-degree full rotation, complete revolution, right? So pi radian would go for how much? Pi radian of arc would go to 180-degree, and 1 degree of arc would go to pi by 80-degree. radian. Pi by 180 degree radian. And if I talk about theta degree of r, that would directly go to pi by 180 degree into theta radian. So question can be asked to compare, to compare this theta with radian, and change the units from theta to radian. So this is one of the important formula you can list up, or you can directly do it with the unitary method. You already know 2 pi radian of arc goes for 360, so pi degree would go to 180 degree, and then 1 degree would go to this much, and theta degree would go to this much. I can even tell you one shortcuts for the unitary method, and even I'll be solving when I'll be teaching you mole concept in chemistry. Thereby also I'll be telling you, quickly you can go for the unitary methods. That's what's 360 degree, pi degree. Without thinking much, just cross multiply. If things are in the opposite, if some things are in opposite, just cross multiply, divide with the leftover thing. So what you get, 360 into pi over 2 pi, that would give you just this, right? And that is nothing but 180 degree. So you see, that's what you're getting. If somebody asks in this way, you can easily tell, right? So you don't need to cram the formula right now. Now, this is okay for us, but like somebody asked a question like, okay, guys, tell me what is of if theta is 90 degree, you need to convert into the radian. So how would you be going? Theta is 90 degree, then pi by 180 degree would into multiply by 90 degree would go give you a particular answer. Like you can solve that. That's pi by 2, right? Pi by 2 radian. For theta equals to 60 degree, again you can solve. That would come as pi by 3 radian. Even you can solve with the formula. You can even go for the unitary method. For the unitary method, you can learn this way: 2 pi equals 360, and for the 90 degree theta for the 90 degree would go to how much? Just cross multiply and divide with the leftover thing. 90 degree into 2 pi divided by 360, that would give you again the same answer, pi by 2 radian. Right. That is again coming pi by 2 radian. So you can easily solve some numericals on this particular topic, and this would create a base for the exams. Now, this is not a question which is asked in the exam. Let me tell you what is a question they asked on this particular topic, but they ask this particular concept. That is, they give a conversion in the basic exams. You can expect this question, or you'll be using in the further concept of physics. Conversion of degree into minute. Actually, now how you convert degree into minute? You know, uh, the one scientist has come and he defined that. What he defined, let me draw a circle. He defined one thing for us. That was what particular thing for us is, he defined 1 minute. What he did, he said it's okay, you are drawing an arc. Okay. But what you have to do is defining this. Just let me create a correct diagram. Yeah. He defined this particular angle as 1 degree. How? What he said? He said you drew 60 part, nearly 60 part, and each part, each part would consist 1 minute. 1 minute has 60 units, right? So 60 seconds. So each unit would have 1 minute. So he did 60 units basically, and each unit he said 1 minute. So what he meant to say, that means he meant to say like 60 minute equals to 1 degree. Getting? If 60 minute equals to 1 degree, then what you mean? 1 minute equals to what? This dash is represented as a minute. So 1 minute is nothing but 1 over 60 degree, right? And so if somebody asks you 2 minutes, so you'll be easily telling 1 over 30. Again, the unity goes there. So somebody asks you example, you tell me about 15 minutes. You compare, convert into degree, right? So 15 minutes. So easily you can tell, right? 1 over 60 multiplied by 15. That would come as 1/4 of degree, right? So these kind of questions are generally asked in the form of small PYQs. MCET again, 2019 one question was asked of this particular topic. So yeah, this has this would create a base for you. So for example, somebody give you one question like this. Let's have a look. Somebody see like also the PDF of this notes I'll be sharing itself in the Telegram, and the this PDF would be in the description box. So plane angle, I already told you. Somebody give you question of theta 30 degree and 12 minutes basically, right? So you have to convert in degree and radian. Popular question. So how would you be converting this? You already know, like 12 12 minutes. Like let's convert this first. 12 minutes is nothing but in the degree, if you would be converting, that would be 1 over 60 multiplied by 12 degree. That's what I told you. Just you have to multiply with 1 over 60. You can even go with the unitary method. So 12 minute would give you how much? That would give you 1/5, and that is 0.2 degree. If this is 0.2 degree, now you got the answer, right? 30 degree, 12 minutes would give you 30.2 degree. So now you can easily draw a diagram consist of an arc, and you can name this angle as 30.2 degree. Easy. So these kind of question you can easily solve. Just you have to remember this one particular formula. I have just made you right upside. Just have a look there back. Yeah, this particular formula. So okay, let's try this. For any minute, you can just for x minute, 1 over 60 degree multiply by per particular x minute. So you will multiply this, and you will be converted into the degree. Okay. So this is important, and this is as well as easy for us to understand. Now let's study a bit more things. What was in the diagram? Now it's okay. Like we studied radian, we studied steradian. We have done some questions on that. Now, how people have defined length, how people have defined mass, why we set time as time, seconds, why we set electric current, how we have defined this particular things. This nobody knows that much, and this is like not exact important for the exam point of view. You cannot expect any question. Only you can expect a few questions that from this table I'll be telling that particular thing, but that's not that much important. Just this is from NCERT table. You can read this. So let's read this with you, like how you define meter. So 1 meter is the length of the path traveled by a light in the vacuum, and where there is no air. So in 1983, somebody came and said that 1/this particular thing is known as a meter, 1 meter. How somebody said about the kilogram? 1 kilogram is the mass of the prototype cylinder of platinum iridium alloy, whose height is equal to its diameter, preserved at the International Bureau of Weights and Measures at service near Paris, France. So this is how like 1 kg was defined. That's again not important that much. This is something which is history of these things, these fundamental units. How somebody defined time. Time is important. The question was asked again. 1 second is the duration of this period of radiation corresponding to the transition between two hyperfine level of the ground state of cesium-133 atom. The question was asked about this particular lines were given and the metal they asked us. So you have to remember the cesium-133 metal that is. Okay. So that you right now you're not aware about the transition and all those things. So that's not that much important. What just you have to know this particular metal was used to define time. Now let's talk about ampere. You can read again, right? This is not that much important. 1 Kelvin was important. Temperature, again, one question was asked about this fraction. So 1 Kelvin is the fraction of 1 divided by 273.16. Still we use this. That's why this is important. 1 over 273.15 we generally use, but here it is very precise to 1.6. Thermodynamic temperature of the triple point of the water. So this is 3 times of the water. So this is again, you need to know that. Triple point meaning is given in the NCERT. You can read this line. So this is something, again, that much, it's not important. So you just have to remember 2 points. One is cesium and 1 over 273.15. And what is the amount of substance? Again, this is pure form of carbon 12 atom. 0.012 kg of pure carbon 12 atom. This is something which is all studied in the chemistry and in the modern physics. So important, luminous intensity, that was not important. You can only know like 1 candela is how much is the luminous intensity in a given direction of a source that emits a monochromatic radiation of frequency. You can learn this frequency 5.4 into 10 to the power 40 hertz. So these were like history of these things aren't important that much. You can easily know like one cesium 1 point for the time. Second, 1 over 273.15, that is triple point of the water. And intensity, you can know just frequency. So with the help of this, if any question by chance comes of this, you'll be able to solve that. So now, what was the practical units to measure small distance? We were just okay with these things, but now like we have to measure some small distances, which we often do, right? So how would you be, this is important table. You need to learn this all. So how you, do this? 10 to the power minus 1 is known as DC, symbol is D. This would be used in physics, chemistry, mind my words. This table is very important. At least learn till 10 to the power minus 15. Till here is a like benchmark you can learn. In it is in minus and this is in plus. Plus 1 everybody knows, but minus 1 always comes in numerical. 10 to the power minus 1 dc, 10 to the power minus 2 is centi, 10 to the power minus 3 is milli, 6 micro, you can easily know, right? Mu is a symbol that is important. Nano 9, so 10 to the power minus 9, 10 to the power minus 12 is pico, and 10 to the power minus femto, atto, zepto, yocto. Deci, centi, milli, micro, nano, pico, femto, atto, zepto, yocto. You can make a song with this and you can learn this because this is important. Repeat with me. Deci, centi, milli, micro, nano, pico, femto, atto, zepto, yocto. Deci, centi, milli, micro, nano, pico, femto, atto, zepto, yocto. This might sound lame to you, but this is, at last, this is very important. Okay. So this was thing which we, there is a small units like 10 to the power minus 2 minus series. And for the bigger units, you can 10 to the power minus 1 desa, hecto, kilo, kg, which you often use. Then you go to 10 to the power 6 mega, giga, tera, petra, exa, zeta, iota. These are 10 to the power 24. The last we created was 10 to the power 24. But if somebody asks you like, what is above 10 to the power 24, so then we need actually practical units to measure large distances. So how would you be going for the large distances? So for the large distances, scientists have named particular things. They have marked thing like light year. So what is light year? It is nothing but it is distance traveled by light in vacuum in 1 year. Okay. So people often get tends to confuse that if light year comes would always 1 year in the terms of year. No, but the unit comes as meter. So it is particular distance travel when the light goes in the vacuum in the 1 year. So 1 light year, how can you calculate? You can easily calculate the speed of light multiplied by 1 year. So speed of light is nothing but 3 into 10 to the power 8 multiplied by 365.25. Okay, one question, people. Tell me why I have written 365.25. Why have I written this as just a minute? Why have I written this 365.25? Everybody knows, right, that one leap year comes after 4 years, right? So every year, like there is 1/4 of the day, right? So this 1/4 like covers after 4 years, that becomes 1 day. And that's why we say particular 366 days in 1 leap year. That's how the logic comes, right? The student even don't know about this, but always remember that 1 year goes with 1/4 of that particular day. So 365.25 into 24. This why we are taking, some books have taken 365. So you just have to take 0.25 for the precise calculation. Into again one particular day has 24 hours, and then 60 minutes into 60 seconds. So you can learn the value. The question would surely come into this. At least you can expect a question in CUET. These kind of questions are generally now being asked in CUET exam. So astronomical unit. So how somebody define astronomical unit? Now somebody has to tell like the distance between Earth and Sun. So you cannot tell with last was you can see the last unit was how much? Iota, right? So 10 to the power 24. So you cannot tell with iota this astronomical unit, because distance between Earth and Sun is something very large. So somebody defined one astronomical unit as 1.496 into 10 to the power 11. Now, parsec or parallatic angle. So people always think that this comes in angle, but no, this is again comes as a unit as meter. So what is parsec? I've just drawn the diagram. So parsec is nothing but, you see, you you travel one arc. You travel the arc of one astronomical unit. Okay, so it's written. It is a distance of an arc of length 1 astronomical unit, subtended an angle of 1 second. So when you travel 1 second, double dash, with 1 astronomical unit arc, then this particular radius is known as parsec. Okay, so what is 1 parsec? That is 3.08 into 10 to the power 16. These all three units are hell lot important for the exam point of view, and this would be asked in the upcoming exams. So that's all for the today's lecture. One question from you guys, like if you can find. Okay, so one question is that, also tell me which is one of the very largest unit for the mass. Question for the homework. Think and tell. Largest unit for the mass. Again, this was a PYQ of EAMCET. What is the largest unit of mass? So this particular unit, the largest unit of the mass is in with the name of an Indian. So you just have to find that and comment down that particular answer, and I'll be replying to that particular person. And even you can join our Telegram channel. The link is given in the description box. So keep learning, keep exploring. Thank you so much. In the next lecture, we'll be covering the further topics, order of magnitude, parallatic angles, how we go for the parallax, how we measure the distance of moon and planet. Then we'll be going dimension. We'll be solving so many numericals. You won't be realizing that when we'll be reaching to the advanced level. But yeah, this chapter again is important. Keep learning, keep scoring. Thank you so much.